All right, in this video, we're going to continue on this module for review, and we're going to take a look at geometric sequence and series. So we have multiple formulas. Let's dive into just the ones for geometric sequence for right now. So again, these two right here are going to help us find any term, any nth term in a geometric sequence. Remember, geometric just means multiplying, right? The pattern is multiplying. We are multiplying by what is called the common ratio. Our pattern is R, okay? So if I started with, say, like 4, and my pattern is to multiply by 3, the next term would be 12. And then so on. I would multiply by 3 all, as I just continue going down that sequence. So these are the two formulas. This is right here, the basic one. This is the one that you're going to get on the test. But I think the generic version is a little bit better with only one small change to it. Diving into it, what it is here's the first term. We're going to apply the pattern just so we can find just n minus 1 times. So we can find any term if we know the first term, and we just need to know how many times we're going to multiply r. So that's the basic version. The generic version, I think, again, takes that restriction that we have where we need to start on the first term to now we can start at any term. UI is any term that they give us, I can start from there. So 1 gets replaced with I. It's the same idea. UN is where I'm ending. UI is what they give me or where I start, the value. R is the pattern. And then the n minus 1 is the jumps, right? How many times are going to apply the pattern? Let's take a look at it in action with the example right here that we have. So, given the following geometric sequence, UN, with the fifth term, or U sub 5, is equal to 60, and the common ratio, part A, we need to find the first term. So, diving into this, right, let's talk about a few things. The given term that they have is the fifth term. So UI becomes U sub 5, or U to the U sub 5, which is equal to 60. Perfect. R, my pattern, the common ratio, is -2. So that's my pattern. What I'm trying to find, right, U sub n is equal to U sub 1. That's where I want to end. I want to end at the value of the first term. So this is where I want to end. This is where I start, the value they gave me. This is my pattern. And then this right here is my jumps. Okay, so diving into it. I want to go to U sub 1. I'm given the fifth term, so U sub I. My pattern, I keep that. But right here, I is where I start. I start at the fifth term. Where I want to be is, the end. That's my end values. I want to be in the first position. So this is the jumps I have to do. Okay, I am working backwards, and that's okay. The formula accounts for that. But you can see that this is my jumps. This is where I start, and this is where I end. So what is my fifth term? 60. Good. What's my pattern or common ratio? -2. So now I have everything to find the first term. I'm going to grab my calculator. I know I'm going to start at the the fifth term, which is 60. I'm going to times that by my pattern, -2. Remember to put it inside parentheses, just so you tell your calculator that I want you to take that -2 and multiply it by the power of 1 minus 5. I'm going to press enter. And I'm going to get 3.75. Now, in Eduelastic, I don't want that. I want it as a fraction. So how can we make 3.75 into a fraction? Click math. Right there is our first one. We want to convert into a fraction. So I'm taking the previous answer and converting into a fraction. And there we go. The first term is 15 over 4. There we go. So in our geometric pattern, there we go. Keeping with this idea, I can find any term. So I can find the 12th term. So instead of, the end goal being the first term, now the goal is to end up on the 12th term. So U sub n now becomes U sub 12, which means n gets to be now 12. U sub I is still what they gave me, so the fifth term, which is 60. So grabbing my calculator, I just need to now put this in here where n is now 12. So I'm going to do 60 times -2 inside the parentheses raised to the power of 12 minus 5. Press enter. And there we go. I get that the 12th term is going to be negative 7,680. Okay. So again, that's using these formulas right here. Again, I like the generic version the best, where I can start anywhere, any term they give me. Again, it's just replacing 1 with I. Okay, what if I want to sum the n terms of a geometric sequence? Well, you have a explicit formula that you can use. You actually have another one, but I think you only just need to remember one because I think it's redundant to think about the other one. But here is the one that I'm written on your paper. And then you have also another method using the summation notation. So let's dive into it. We're going to use both of these to show you that you're getting the same answer. So let's go down to part C. Here, we need to find the sum of the first 8 terms. So we're looking for S sub 10. Using this summation notation, remember, really what we're doing is we're putting this as UN. We're going to find each term starting at 1, ending at N, and we're going to add the terms together. So how does that look? Well, I'm looking for S sub 10, which means N becomes 10. So wherever you see N, now it becomes 10. So I'm going to start with my index starting at 1, ending at 10. It's going to find each term starting at U sub 1 and add all the way up to the 10th term. So again, U sub 1 plus all the way up to U sub 10. It's going to take all those terms and add them together. So grabbing your calculator, press math, go up to 0 or just press 0. You're going to have X is my index, and so instead of K, it's going to start off with 1. I'm going to go to the 10th term. There we go. And then inside the parentheses, I'm going to put that explicit formula that I've been using for part A and part B. We're starting at, again, U sub 5. So the fifth term is 60. So I'm going to start at 60 times my pattern -2. And then the jumps I need to make. Remember, I'm going to put X there because that's my index. Is going to start at 1 and go all the way to 10. I'm going to minus, where am I starting? What value am I starting at, or what term I'm starting at? I'm starting at the 5th term. So I'm going to minus that, and there we go. Press enter, and I get this, negative 1,278.75. Now, I want to round it to the nearest integer. I don't want any fractional part. I want it whole, a whole position. I want just the integer value. So if we look right here, I'm looking at the 8. I want to round to the ones place. Look to the number to the right, it is a 7. So again, looking at here, looking to the number to the right, it's 7. So that means 8 now becomes 9. So approximately the sum of the 10 terms is negative 1,279. Okay, how can we do it looking at the formula? Here's the formula. We need to know the first term, which we do know as a fractional form. It's 15 over 4. Perfect. Again, we got that from part A. I know my pattern. It's -2. And again, N, I'm finding the sum of the 10 terms. So wherever I see N, I'm going to replace it with 10. So grabbing your calculator, press alpha y equals, making a fraction. I'm going to actually make another fraction for my first term. It's 15 over 4. Then I'm going to multiply the -2 raised to the power of 10. Drop down, put that -1, close that parenthesis, and again, put -2, that's my R value, -1, press enter. And here I get a fraction, but I can convert that into a decimal by just going down, press enter, and I get the same value. And again, the same idea, looking at this value right here. I'm going to round to the nearest integer. So take a look at the 8, the ones place, look to the right. I'm going to round up. So it's going to approximately be negative 1,279. So I get the same value for the first sum of the first 10 terms using either method, so whatever you prefer. I like this method right here. If you don't know what the first term is, this method is pretty good when you know the first term. If you have any questions, raise your hand. Otherwise, I will see you in the next video, guys. Have a great day.